Hey, welcome guys. This is Naraz and Eric from NTech, and today we're going to talk about infrastructure as code for Azure. This is particularly focused on .NET developers with Azure as a platform, and in the future we're going to do other infrastructure stuff, but today we're only going to talk about Azure, how this works, and how you can get started with infrastructure as code for Azure. Let me introduce you to Eric Popovker, who is our CTO and who's going to lead our today's webinar.
This is a webinar is for people who work in .NET and Microsoft field and who are developers by day, but also would like to get a bit more into the DevOps, which I guess everybody is supposed to be doing now, but I'm not really clear how many people actually fully understand. So this webinar is gonna give you a little taste of what infrastructure as code is all about, and what are some of the better tools for Azure that allow you to implement infrastructure as code, and what is infrastructure as code other than a three-letter abbreviation for something. So what is infrastructure as code? Infrastructure as code is basically a way to automate and script deploying and provisioning data resources onto the cloud. Now we can just write a couple of lines of code and create servers, create databases, create pretty much anything. Like this gives you so much power, but just remember, with all this power, make sure you use it responsibly.
So Eric, so let me interject a little bit here. So, why would you use the infrastructure as code versus TeamCity?
Is a little bit of it serves a little bit of a different purpose. TeamCity is a CI/CD tool, and it basically allows us to deploy our projects, our web applications and Windows services and others, to deploy to either a hosting environment or a server, that you have internally. But infrastructure as code can be used as a part of the deployment, and it's commonly used that way. But it's basically you can integrate in infrastructure as code in TeamCity. You can do it in Azure DevOps pipelines. Like, it's pretty independent in Jenkins or any other CI/CD tool. So infrastructure as code is just one of the steps that usually happens during the deployment. And what it usually does is it checks if kind of infrastructure declared or described in your scripts matches what's currently on production, or a different environment where you are deploying. If it's the same, it's great, it doesn't do anything. If it's different, then it creates a bunch of commands or functions which get executed as a part of the deployment to make sure that the environment you are deploying to matches what you have in your scripts. And
got it.
It's very similar. Like, if you are doing like a SQL database deployment in .NET world, you use a database project type for it, and a similar thing happens where during the deployment, the system checks if the schema inside of the database project matches the actual schema of the actual database. And if it's not the same, it runs a bunch of SQL commands to update, add columns, update names, change sizes, add store procedures. And after you run all those commands, the database where you deploy to is going to be the same as the project you are deploying from. So infrastructure as code is pretty much the same thing, but unlike deploying a database, here you are deploying your whole environment, which includes servers, databases, routers, virtual machines, whatever cloud offers you these days.
Got it.
Right. So what are the various tools that are currently available to do it in Azure, in .NET/Azure world. All right, so there's 4 main options in the, for the Azure tools. There's many others actually available, including some of the old ones like Chef and Puppet. But these are the ones that I've been looking into, and have a pretty good idea of how they work. So there is the native Azure option, which Microsoft provides, which is ARM templates. There's Terraform, which is pretty popular, open source product. Ansible is similar to Terraform, and Pulumi is kind of a new kid on the block, and it has a whole bunch of new options, and it takes a bit of a kind of a modern approach for this. So let's go through them in a bit more detail. Each one of them, is pretty well maintained and fully featured project, and all of them have features like previewing changes. Like, let's say I want to add a new virtual machine to the script, and when I run it, I can basically, before running it, I can preview the changes that are going to be made. So it will say, okay, this new virtual machine is going to get created. Rollback changes. So if you roll the changes, but you now see some mistake or there's some issue with the changes you rolled, you can roll it back. Pretty much all the tools have them. Cleanup. If you want to just create an environment, play around with it, or test a feature on it, and then quickly remove it, that's easily possible. Some form of script code, some form of reuse of scripts or code that you're writing. That kind of varies between various tools. All of them offer something, but some of them are much better than others, as you will see. Easy integration into deployment pipelines, CD pipelines. All of the tools have it. And then, obviously, you don't want your script and code to be living in some external system without anybody being able to access it. So all of these tools allow you to, store your scripts in whatever you prefer the source control. So you can version it, and you can see the history and who changed it and why. But all of these systems, they also have some differences. In some cases, pretty major. So let's start with 1 second. The first tool is ARM templates. So Microsoft introduced it a while ago, and it's like a JSON script that you write, something like this. So where you specify or declare what your resource is going to look like, what type it is, and what pricing tier you want to use, what location it is, and things like that. It's pretty simplistic, and works pretty well. If but it's only the first option. It doesn't have a very it's more just writing kind of YAML JSON configuration files. So it's not the same as if you're using them in some sort of declarative language. But Microsoft recently tried to fix it, and so they introduced a layer on top of these ARM templates, and it's called it's more of a kind of a programming language called Bicep. So when you try to do the same thing using Bicep, it basically kind of looks like this. So you have your parameter. You can use reusable parameters. You can declare resources. It kind of looks like a real programming language, but once again, it's what they call the domain-specific language, DSL. And it's not, for me, not really exactly clear why Microsoft decided to invent yet another language for this when they have already C#, VB.NET, and F#, which are probably not are not going to be the domain specific for this. But why invent kind of a new language when you already have something? Probably need to do. So there's a couple of good things about it using the ARM templates. The good is, if you're a Microsoft developer and your company has one nice little bill from Azure or that you get every month, you don't have to deal. You can just put ARM templates and use the same. It's the same bill if you need to use some paid features, which I'm not even sure. I think it's mostly free, and you're basically sticking to the same stack. You don't need to go to third party. Since it's Microsoft service, I'm pretty sure they're going to keep it up to date, to all the Azure SDKs, and that's a really good benefit of using this tool. The problem is, again, if you're a developer, learning another language is not very difficult, but knowing another language is a different animal altogether. So yes, you can learn Bicep, you can learn JSON, but actually learn the ARM templates JSON, but actually to be able to become proficient in it can take a good amount of time. So yes, you can learn it and everything else, but the learning curve is not the same. The cost of entry is not the same as using a language that you already know. So let's continue the Terraform. The Terraform has been around for a while in the development world years. Like, what is it, 2014, 22, 8, was like 50 years probably. So, they're well regarded, and they have their product is open source, but I think but they also have a hosted solution, which I need to double check that. This product was written in Python, and it's extremely friendly to the Python developers. But they provide Python and TypeScript support through SDK. The main way that you declare configuration is using something called HashiCorp config language. So it looks kind of similar to the ARM template JSON, but once again, I don't know, the naming and everything else is all different. So you I'm sure it's not very different from any of the other tools that provide this declarative type approach, but you have to deal with another language, another third-party service. So the other issue with this tool is, unlike many others, like the state of the deployment and the state of the infrastructure, you have to keep track of yourself. So you have to do it manually, as opposed to other tools like ARM templates and Pulumi. I know they basically allow you to host a state in the hosted solution, so you don't have to worry about it here. That's pretty much for Terraform. It's a big, well-supported product, but once again, it's a third-party tool, so you have to integrate with it. You have to use a separate documentation. You have to learn a separate kind of language and things like that. So for that world, if your company is already using it for maybe it's not Microsoft only shop and it's using it for other things, then obviously it's probably a really good option. But if you're building a new product, I don't think that would be my first choice. Actually, yeah. So Ansible. It's actually Ansible. I made a small mistake. The Terraform actually is not written. I'm not sure what it's written in, but you can either use declarative approach or you can use Python and TypeScript through SDK. But Ansible is the one that is written in Python and very friendly to Python developers. It has its own language declaration, like that looks like this. They use YAML. So if you look at it, I mean, all of them look kind of similar. Again, naming conventions are different than everything else. But this guy, the main difference is they use YAML. They're open source, even though they're owned by Red Hat. So I'm sure Red Hat is providing a lot of the support. Big community, like plenty of stars on GitHub. But as a problem with all these other tools is, you have to learn a new language to be able to deploy and write scripts for infrastructure in Ansible. It's also very well regarded. So I think Ansible, Terraform, you can probably, depending, if you're a Python shop, Ansible is probably a really good choice because they're really Python centric. If you want some established player and you are not only doing Microsoft, but you're doing a whole bunch of other clouds, Terraform is also a good option. So for the last option, we have Pulumi. So Pulumi is a bit newer than most of these others. The Pulumi is, they kind of have taken a little bit of a more modern approach. They support, out of the box, they support like TypeScript, Python, C#, Go, and a whole bunch of other modern languages. So it depends, whatever language your developers already know, or you already know, you don't have to learn a whole new language, how to build it, how to deploy it, how to compile it. It's already out of the box with Pulumi, which is really, really great idea. And what it lets you do is, all you have to do is set up a new project, connect, use a NuGet to get the Get Pulumi package, and right away you get all the IntelliSense. You can create resources. There is a little bit of a learning curve to set up the first project, but it's nowhere even in the same range as most of these other tools. So an example of a Pulumi project is something like this. You have your C# class. In this case, I need to check if it works in VB.NET, but probably yes. And you basically just use C# to create. So if you want to create a new resource group, you use this code. If you want to create a new storage, you use this code. It's pretty nice. Since C# is compiled, you don't need to worry about compile time errors, and runtime errors are much easier to recognize and fix than all these other declarative YAML and JSON and all that stuff, and bicep and things like that. Like with C Sharp is, you basically leverage C Sharp. You run it, if you misspelled location, you're going to see it right away, and you fix it. You don't have to wait until you actually like try to run this infrastructure and make it and push it to Azure. So this is to me like by far the main benefit of this tool is being able to use C Sharp, which is I think for developers, like if you can just tell them like, okay, you can keep using your Visual Studio, you can keep using C Sharp, just get this package and you can you become the king of all the infrastructure. I think developers would really like that. It's the Pulumi is really good about keeping their Azure integration aligned with the latest Microsoft SDKs, so you don't have to really worry about Azure introducing some new functionality and waiting forever, until Pulumi is going to have support for it. They're really good at it. The documentation is really good. Like you basically can go to any page. Like let's say I want to create. You just let's say I want to create a new virtual machine in Azure. So you go to the documentation, you click here. So and then you basically have like in every language, TypeScript, Python, Go, C Sharp, Java, YAML, forget about YAML, C Sharp, and you can see exactly like how the virtual machine can be created with all the options. Even like in most cases, the options that they provide and describe, they are fully sufficient. But even if you are like something is not really clear, you can always just go to Azure regular documentation with for creating a virtual machine, and you can find and because the naming is very much consistent, like Azure Resource Group, Azure Network, Virtual Network, they match Azure Classic, Azure Native functionality by name. So if you just search for this or similar name, you can easily find it directly on Azure documentation. You can find all the supported, anything that's missing from here, which, like I said, is very rare. The only drawback with Pulumi is it's not as established as most of these other tools. So if you're a little bit worried about, Pulumi, I mean, they seem like they're supporting a lot of things, and I know a lot of companies that have been using it, but they're definitely not as big as a lot of these other tools. So just as a small demo, I'm going to show kind of how Pulumi works. I have a little project here, which is basic. I'll just run it for you. It's based on like a sample from the Azure, from how to build a .NET Core app with the Azure SQL. And Microsoft really likes to-do lists. So this to-do list, you can just edit it, you can create it, and do whatever. But this is actually not the project that we're gonna show it a bit more in the future. The actual thing I wanted to show today, I don't know why I showed it, but the actual project I want to show today is this C# project that basically creates a bunch of resources and pushes them to Azure. So if you look at the code, you basically have your stack. You're creating a resource group with this name or similar name, which I'll explain later. You're creating a storage account that's using this resource group. So resource group is coming in here. The names here are a little bit, they're not what you think they are. So like this is the first parameter in most of the resources is a name, but the name that is not the actual resource name. It's a name that Pulumi is using to track this resource. The actual name is here. So as you can see, because for storage accounts, the name doesn't allow dashes, this will work because the actual name is here, while the Pulumi name is much more flexible in its name. So, you take, let's say, if you misspell something and make an error, as you know, you can just, during build, there's an error. I need to fix it. So much better than YAML and JSON. YAML and JSON, in a lot of cases, they have a schema verification, so some of them work and some of them work really well. But this is, good old C#. I think it's a lot. Well, it just puts you in this kind of a developer state of mind, like you're just developing a C# program, as opposed to some declarative, descriptive YAML JSON. So after that, there's also a small piece of code that basically, after you create the storage, like it outputs the account primary key, so then you can use it in your config file. So that's pretty much it. I'm going to actually deploy it. So to deploy it, I'm going to show you what environment looks like before. Look, there's no storage account. And then I'm going to deploy it, and the storage account will magically appear. You guys ready? To do it, you need to open something called, I'm going to show you how to open it also, because it's not super clear. So you go to View, and you go to Terminal. And then here, you can select, you can either use PowerShell or Command Prompt. I kind of like Command Prompt, so I use that. So you go UCD to the project that does Pulumi, in this case, to do app Pulumi. And then you use Pulumi commands. Pulumi commands are like similar to Git commands. You just start with this Pulumi, and then you can, let's do preview first. So Pulumi preview is just going to show us what's going to happen. So I'm uploading it to the development environment. And so to do app Pulumi, so basically what it's going to do, it tells us, it's going to create a new resource group called to do app RG, and it's going to create a new storage account to do app SA. So now let's actually upload it. So to deploy it, you do Pulumi up. It's actually going to do preview again, and it's going to confirm it with you. There's a way to bypass all these confirmations, but so I can press on details, for example, and it's going to show me like all the details. So resource group is going to be in location East US, and you see a resource group name. It actually, like if I use a resource group, the Pulumi resource name is not the same as the actual resource name. What it does is it adds, if you don't specify like an actual name in resource group options, it will use the name that is using for the Pulumi resource and add some like salt suffix to it. And it's useful like to keeping, if you're creating multiple environments with the same kind of names, to keep them unique. But if you look at the second one where I specify explicitly the name, the account name stays this. It doesn't have the extra suffix. So that's a way to kind of overcome the default behavior. So now, do you want to perform this update? Yes, please. And now we just sit here. So one cool thing about it is like you can click on the link here. Yeah, here's our storage account. Here's our resource group. Voila. So this, I think that's pretty much it for this webinar. We basically went. Oh, I shouldn't open this page. Also remove it, please, Naresh. So in conclusion, I ended up using Pulumi because it has, well, primarily because it has C# support, and it's very easy, like for a developer who lives and breathes C# to just easily use Pulumi. Other tools are really good also, but again, if you're starting on a new project or you are Microsoft shop looking for good infrastructure as code, tool Pulumi is definitely worth your time. That's pretty much it. Any other questions?
Thank you for attending, everyone. If you have any questions, please feel free to reach out to Eric at entechsolutions.com. Thank you again.